Okay, so today we have come to our learning outcome for this unit. So the unit is database design and development. We're looking into our indicative content. What we will do today. Just 1 second, is loading up. It's slow, this machine. So in today's session, we're going to be able to review the process of design and implement of a database. So our indicative content for today, we're going to look into database architecture, database documentation components, and we will look into design review, code inspection and security inspection, and post-implementation review. So in our previous tutorial, we looked into DBMS, and then we looked into how to implement a database through data definition and data manipulation. So in today's session, we have now come to look into the architecture. So by architecture, we are just going to define the 3 tiers that are involved when it comes to the architecture. So what is a schema? So by schema, we are just going to identify the 3 levels required for us to create our database. So we have an internal schema, which is going to describe our physical storage structure. And moving on, we have a conceptual schema, which is going to describe the structure and the constraints between our database for a community and of the user. And then lastly, we are going to look into the external schema, which is going to describe the various user views. So this is going to describe our user interface. So this is how our schema our architecture would look like, where at the top level, we have our user interface. So we have our user, which are storing data into our database. And after that, we have our conceptual, which is just our API. We can classify this as a application portable interface, which connects our external level with our physical level. And obviously at the bottom, we have internal level, where we now storing all our data, and then we have our physical data organization, which is our database. So what are the 3 schema architecture? So these all of them are now able to access the same type of data, and with the database architecture, is now able to change database storage structure without affecting any type of user. When it comes to an internal structure, our database should be unaffected by any type of physical change to the other layers. So what do we mean by documentation? So whenever we are creating our database, we're going through all these tiers, it is important to document all this information. So we need to have a data dictionary, a database administrator guide, a database architecture documentation, and lastly, database functional specification. So what do we mean for data dictionary? And this is simply going to include all our electronic files in the many relational database management system. And with the database developer, we can now also extract useful information from our file. Here, for instance, we can list the file. We can now assign number of records for each file, which will be included. And then we can also name the type of our database field. Also, we have data element number, which it is always agreed upon a unique data element name. So what this we do, you have a short description of what is the element. You also have a security classification for the data element. And then you're also going to be listing of related data elements with important relation to the specific data. Then we have typical elements, which we will now include in the database documentation. So we will have a code format, we'll have a default value, then we'll have an element coding providing explanation of the coding with the validation and verification rules, reference to this, and obviously a table of reference. So let's watch a quick video which will give us a better understanding of our database system.
In this presentation, we will see about the database system architecture. We are now in part 1 of the database system architecture. From the last few presentations, we realized the importance of having DBMS by organizations because data is crucial. And the volume of data handled by DBMS is really fascinating because the data that is processed by DBMS is not just the bit of data or bytes of data. They range in kilobytes, megabytes, gigabyte, terabyte, petabyte, exabyte, zettabyte, yottabyte, and whatnot. In the coming future, we may also end up in more data volume than what is specified on the slide. So when a database needs to handle this much of information, obviously the main memory cannot handle this, though the main memory is faster in nature. But this main memory cannot store the database because it's volatile in nature. At the same time, the secondary storage devices like the hard disk or the SSDs, the solid state drives, will also not be sufficient due to the increased volume of data. Then what's the solution for this? Because this contemporary world is handling an enormous amount of data. So obviously we are in the need of storage servers or data centers or cloud that can handle large volume of data. The reason why I am projecting this is that I'll give you a real-time example. Just see Facebook, how much volume of data it is handling every day. Take another server, the WhatsApp server, which is handling an enormous amount of data. Every day, every minute, every second, it handles a large volume of data. At the same time, whatever we post, it is stored in their servers. Let's say you have posted your photo in your Facebook account, and later you have decided that you don't want that photo to be posted. So obviously we will be deleting that, isn't it? So when you delete, it's just deleted from the view of yours and your friends. Is it actually deleted from the Facebook server? No, it will not. So whatever we upload, everything is stored in the servers. And think about the complexity of handling such high volume of data. But still, our technology and servers are able to handle this. That's the part of being in this contemporary world. And coming to the DBMS architecture, this is also referred as the database system structure. And what we are going to learn in this presentation is the part 1 of the database system architecture. At first, let me show you the architecture diagram. Here is the database system architecture. If you see the diagram, we can see the users are at the top level. The naive users, the application programmers, the sophisticated users, and the database administrators. Obviously, each users will be preferring some set of tools for their activities. And here is the tool level. And if you see the architecture diagram, we have two important components, the query processor part and the storage manager part. We will come to this later. And also, if you see, the databases are actually stored in the disk. So in this example, we are assuming that the database is actually stored in the disk, and that's why this storage is referred as the disk storage. So in the database architecture part 1 and part 2 presentations, we are going to exclusively focus on all the individual components that constitute this database system architecture. I mean the components in the query processor as well as the storage manager. In part 1 of database system architecture, we are going to exclusively focus on the storage manager and the disk storage. I mean, we are going to focus on the buffer manager, the file manager, the authorization and integrity manager, and the transaction manager. Also, we are going to see about the data indices, the statistical data, and the data dictionary. So let's see one by one in detail. So we are clear that we are going to focus on the storage manager, which is this. So we are in this part and we are going to focus on all these managers. Before seeing the managers one by one, let's understand why do we need the storage manager and what role it plays in the database system architecture. Basically, this storage manager provides the interaction between the low-level data stored and the application programs. If you see the architecture diagram, this storage manager provides the interaction between the application programs, that is from the top level, and the data stored at the low level. So here is the actual data that is stored, and to be precise, here is the actual data that is stored in the database. Actually, this storage manager only handles all the queries that are submitted to the system. What do we mean by this? If you see the architecture diagram, the query processor processes the queries and this will give the request to the next level, which is the storage manager. And that is why the third point says that this is also having an interaction that is received from the query processor to the disk storage. And also this storage manager is having the interaction with the file manager. You may be asking me a question. We have already compared file system and database system, and we understood that databases have more advantages over file system in effective storing and retrieval of data. Even though we are saying that it is a database system, internally it is made up of files only. But it's not going to work as the regular file system, rather it is going to work differently. Why? Because we need to effectively store and retrieve the data in database management system. At the same time, the various drawbacks that we have seen with the file systems needs a solution here. Though we are using internally all files, but this is not going to work as per the file system concept. It's going to work as per the database system concept. And also we know that only low-level data are stored. And this low-level data is actually the raw data that are stored on the disk using the file system provided by the operating system. And obviously, whatever the interaction that we make, see, we may do some insertion or deletion or updation, whatever it is coming from the front end or from the high level, those data have to be stored in the database. To be precise, it has to be stored on the disk only, because this database is on the disk only. So all the raw data are stored on the disk, and what format it is going to use? This is going to use the same file system format that is provided by the host operating system. So we are clear that if data are to be stored on the disk, it uses the file system provided by the operating system, and these raw data are provided from the users or from the application layer or from the topmost layer. And what about the DML commands? What do we mean by DML commands? These DML statements are the statements that deals with the insertion of data or deletion of data or updation of data or sometimes selection of data from the databases. We know databases are going to store the data and data-related operations are dealt by the DML statements. Example, select, insert, delete, update. No worries, in the last lecture of this chapter, we are going to focus on the DBMS languages. At that time, you will be able to understand what is DDL, what is DML and other languages. Also, we have a separate chapter called SQL where we are going to exclusively focus on the SQL, the structured query language, along with DDL, DML, TCL and DCL operations. I know things will be unclear, but for now, just understand DML is data related. So when such commands are received, this storage manager only translates the various DML statements into low-level file system commands. Why? Because the internal organization needs to be supported by the operating system, and this operating system obviously will be using some file system, and whatever the data manipulation language commands that we give, these things have to be translated into the low-level file system commands. In simple terms, storage manager is responsible for storing, retrieving and updating the data. Now we will see the various managers that are there in the storage manager. As per the architecture diagram, we are sure that these are all the 4 components or managers in the storage manager part. Number 1, the authorization and integrity manager. Number 2, the transaction manager. Number 3, the file manager. And number 4, the buffer manager. And also, as already stated, we are going to look at various data structures, the data files, the data dictionary, and the indices. We will see one by one now, but let's go to the architecture diagram. At first, we will focus on the first storage manager component, the buffer manager. And this buffer manager is actually responsible for fetching the data from the disk storage, here is the disk storage, and into the main memory. And also, this buffer manager decides what data to cache in the main memory. I hope you are already aware of cache memory in computer systems. This memory is mainly used for faster access. So buffer manager takes care of this. At the same time, this buffer manager is very crucial in terms of another important operation, that is handling the size of the data. We know the databases will be larger than our actual main memory. So this buffer manager will also take care of this memory management. And coming to the second one, the file manager, we know already this is mainly for allocating the space on the disk storage. We know actually the databases are already stored on the disk, and we may be inserting new data or deleting the existing data or updating the existing data. This file manager is responsible for allocating the space on the disk storage and also the data structures. We have a lot of data structures followed in the disk storage, and this file manager is used to represent the information stored on the disk. And coming to the next one, the authorization and integrity manager, this component or this manager is used to test for the satisfaction of all the integrity constraints that we enforce on the database. Say for example, balance should not be less than 0. In such case, if any operation that is carried out on the database where the balance is going to be 0 or lesser than 0, that operation needs to be aborted. That should not be permitted because we have given an integrity constraint that balance should not be less than 0. So all these
So the video just showed the 3 layers and how these communicate with each other. So coming back to our presentation. Looked into we have seen how these databases are subdivided, and also here we have to look into what table documentation is, where we need the database table documentation, where each can now be drawn for our SQL database and our SQL command So we now have a database name, a table name, table owner name, data element column and details, keywords for the element, database index information, technical table organization. So here we have automated tools for documenting our database. So as you can see, there are a number of automated documentation tools available to assist the development of the database. Then you have best approach, which it relies on the combination of automated tools and the skills of experienced business analyst. So when it comes to a database development review, we need to look into the four type of reviews, which are there are 7 basic of them, where we have a conceptual design review, which allows us to validate the concept of our data and the proposed application. Logical design review, and which we will now review all the elements, description and relationship, as well as comparison of the possibly remediation. Then we have physical design layer, where the database is reviewed in detail to ensure that all the database parameter are setting and the other physical design choice were made. Then we have organizational review, and we have SQL and application code review, where we're going to review our code. Then we have pre-implementation design review, and lastly we have post-implementation design review. So we have covered all of them in detail. So now we have security inspection, where there are elementary security measures that we must take into protect our database from common threats. So we need to look into access control and authorization steps. We need to look into access databases configuration, access database platform interaction, secure communication, patch the database, application usage of the database. Then we look into log and event review and embrace security. So these are all the security inspection that has to be done. So this was everything for today. Is there any question?
No.
Okay. Thank you very much for joining, Shalom, and I'll see you tomorrow, where we'll have our assignment discussion. Would you need a tutorial for that, or you can go through by yourself?
We can do the tutorial.
You can do?
Yeah.
Okay, no problem. And I will see you tomorrow.
Bye.
Thank you. Bye.